You want to lick that? Pretty rainy day, but I'm pretty excited. We're going out with some of the sailors competing in the Swedish sailing teams and now training for the Olympics. We're heading out here and we're gonna join their training session. The major reason I wanted to come out here is to show you the gear and the equipment that these guys are using. These lasers that we see behind us now are mostly made out of fiberglass, as opposed to the 49er that we have over there that has just a variety of different materials, a lot of composites and fiberglass and carbon fiber. The equipment is of course very important in most sports, and a lot of times it's a matter of cutting the weight of the materials.
Being light usually means less energy is required to go fast, but a material can't just be light. It also has to be strong enough not to break under all kinds of forces. And this is where material scientists come in, and why research on lightweight materials is not just being used in sports equipment, but an important part in solving big energy questions.
And as you can see, the end results are quite complex.
I'm meeting with Dr. Martin Fagerström, who is an assistant professor of material and computational mechanics at Chalmers University of Technology.
The problems with the materials today are that the density is a little bit too high compared to what you would like. So basically they have very good properties for many applications, but they're more or less too heavy for certain low-weight applications, like meeting the new demands for cars.
These new demands mean, for example, that we have to cut carbon dioxide emissions with 40% by 2021 compared to 2007 levels. And reducing the weight of vehicles is one way to get closer to this goal. There are two main approaches to do this. Either we take materials that we have today and simply use less of them. Basically, we use less material but get the same effect. Scientists are looking into new metal alloys that will have the physical properties needed to be used in vehicles but won't require the same amount of material to be used. And the other approach is various composite materials.
A composite material is a material that contains at least two different other materials. So it's a mix of at least two different materials with very different properties. And the good thing is that if you mix these two materials, you will get a new material, a composite, which has some wanted properties that you're after.
A composite has at least one part what is called a reinforcement material and one matrix surrounding and supporting the reinforcement material. What we're after is a combination with properties different to the individual components, like lightweight but also strong and durable. Carbon fiber or carbon fiber reinforced polymers are well-known examples of composites that are today used in all kinds of things from sports equipment to airplanes. But it wouldn't be safe to build cars out of mainly carbon fiber, so research is focused on developing new composites that will have the strong properties of metals like steel, but being a lot lighter.
This is a carbon fiber epoxy material. After crushing, you have these different layers in this kind of specimen separating. So you have it splits in different layers, everything happening at the same time. And the more the material breaks, the more energy you consume.
This is favorable because we want the material to take up the energy of an impact, not the people.
So this is really what you want it to look like.
Inventing the material is of course only the start. After that comes all kinds of rigorous tests.
This half of the building here is dealing a lot with the manufacturing techniques of different materials and how we can make sure that we can actually work with the material that we have after it has been developed. Something we kind of take for granted is easy with metals because you get a metal sheet and then you can form it, bend it, mold it and drill it. But then if you have new lightweight composites that we're talking about, you got to make sure that we can shape them and not shatter them when we start playing around with them, right? Right. Yeah, spot on. Yeah.
Once we have a material we can work with, it still needs a lot of testing before we know it's safe enough to be put into cars. And that brings us back to sports equipment. The sports scene has actually shown to be surprisingly valuable here. Sports equipment with new materials gives a quick turnaround of results on how the material behaves in many different conditions, without risking lives. And you know these athletes will put their equipment through some serious testing. Some of which is actually done here at Chalmers in the 260-meter long towing tank.
We think we know how this works, but here we get the correct answer.
So lightweight materials are going to be extremely important in the future of transportation, and a lot of times this, of course, in order to cut the cost of energy and the use of energy. We're extremely thankful that we've been able to come out here with these guys today, and of course we want to take this opportunity to wish them the best of luck in future competitions, and make sure you keep an eye out for these guys in future Olympics. All right, see you soon.